Hello, this is Chris Lobban and Maria Schefter, your COVID-19 field trip team, on the way to Lost Pond. We've taken the road past Two Lovers Point and the Northern Sewage Treatment Plant, and now we're coming down the hill past the satellite dishes to Tangeesan Beach Park. There's a walk in through private property at first to where we enter the beach. This is just a little quicker than walking along the beach, and it's a long walk today. Even though there are a lot of people here today because it's Memorial Day weekend and the public beach is still closed to group activities, there's still ample room for social distancing. This view is of the beach between Tangeesan and our starting point by the undercut rocks. We will start with the geology, the beach components, the beach seeps and the notches on these rocks. The tide is fairly low now, and you may notice that there is a big notch at the base of the rock. This has been eroded by a combination of physical, chemical and biological factors, but especially by limpets grazing on microscopic algae on the rocks, which they do by rasping away both algae and rock. Over centuries to millennia, these small animals have worn the rock away one grain at a time. We'll see some of the limpets shortly. There is another notch about 5 feet higher, and this is about where sea level was when people first came to Guam, and this area was a mangrove. This we know from studies of the bones and shells of their food they left behind. There are still more notches further up on Two Lovers Point because Guam was raised out of the ocean through alternating periods of lift and stasis. But before we get to the limpets, we encounter the first of many beach seeps. This is just a small one. There are many more along here and along Tumon Bay, some big springs. These are places where fresh water overflows from the water lens. Fresh water percolates down through the limestone until it meets the salt water at about sea level. It pushes the salt water down and in the middle of the island piles up above sea level, but here at the edge of the lens it flows horizontally out of the rock and across the beach, forming a delta every time the tide goes out. Some springs are substantial. If you've been swimming in Tumon Bay and encountered cool water that made the seawater blurry, that was fresh water from a spring. Beach rock, cobbles and sand on Guam beaches are all limestone from once living organisms, so biogenic, as is the cliff on our right. In the solid rock near the water's edge, we can sometimes see the shapes of the ancient corals. The remains are part of the ancient reef structure and can be seen here where the rocks have been scoured smooth by sand. The highly eroded limestone, or karst, on the shore has the same structure, but it's not visible. Waves tend to sort beach deposit by size, so that there will be areas of stones and areas of sand. These areas change during the year as tides and waves redistribute the pieces. Most of the larger pieces are recognizable as coral, but we can also recognize fragments of snail shell. There would also be pieces of crab shell, fish bones, etc., all calcareous. Several seaweeds, such as this halimeda, green in life, are calcified and contribute to the sand. Dead seaweed and animals from the reef flat wash up onto the shoreline, and the organic matter gradually breaks down. Beach flies, hermit crabs and ghost crabs are among the decomposers, and the organic material washes down into the sand and disappears, naturally, if the beach has not become compacted. Hermit crabs feed on the organic remains and also reuse old snail shells as portable protection, the original CYA. As the crabs grow, they have to swap into bigger shells, which they do collectively by lining up in order of size, and then all quickly switching up. There are also many ghost crabs skittering around the beach and diving into burrows. When one is startled away from its burrow, it first runs crazily, and if it doesn't find a hole, shuffles down into the sand and tries camouflage and immobility. This little crab has managed to bury itself right there. Hello. Yeah, he's going to play dead now, but he's not really. Oh. The intertidal zone is the part of the shoreline that is underwater at high tide and exposed to air at low tide. The plants and animals that live here are marine and must be able to tolerate terrestrial conditions that can include heat and salinity changes from rain or drying. Algae sometimes form water-holding cushions to stay wet. Limpets make shallow pits in the rock to fit their size and then seal the rim of the shell to prevent water loss. This 3-inch sea slug is an unusual find. I've never seen one before on this walk. It is a shell-less mollusk. Terrestrial plants extend out across the beach as far as they can tolerate salt water. Sand extends above the intertidal zone, but it is subject to periodic disturbances by storm waves, and the sand gets very hot, so it is something of a limbo or purgatory between the sea and the land where the dead go to get recycled. Grasses, beach morning glory, and beach pea all have horizontal stems that allow them to stretch over the sand, supported from roots further up. Seedlings of the woody plants, like half-flower, germinate out in the sand where they will not be able to grow very long. Storm waves will prune back this vegetation. The line of well-established bushes along the shore marks the edge of this disturbance. This beach morning glory is well developed now. Its leaves and flowers distinguish it from beach pea, which has the same growth form but of course has pea-like flowers. Several plants along the seashore have fruit that float, and the same species turn up in the strand vegetation of islands all over the tropical Pacific. Among these is puting, the fish-kill tree, which has night-blooming flowers that look like fiber-optic lamps and are, or were, pollinated by bats. Its big pyramidal fruit float even when green, and will be washed away by storms and perhaps deposited the same way on other islands. Coconuts, half-flower and octopus bush also have buoyant seeds. There are 2 really salt-tolerant woody plants on rocky outcrops along the beach. The first is Bichia, known locally as Gausali, whose white trumpet-shaped flowers can be seen here and all up the cliff face. It grows on exposed limestone where there is no soil and, one would think, no water. Yet it grows in cultivation in soil, for example in the University of Guam Agriculture Building quadrangle. What does this tell us about habitat and competition? The other bush that grows without soil is Pemphis. This is Pemphis. Rhymes with Memphis, but it starts with a P. And I want to show you this because on this side of the island it grows pretty tall. I'm only 3 feet tall, but this must be at least 10 feet tall. And it's got these little white flowers in the leaves. We'll take a close-up in a minute, and then when we go to Paget Cave, we're going to show you how it grows like bonsai on that side in all of the wind. Here is how Pemphis looks on the terrace above the waves at Paget. Just want to show you, it is the same plant that we saw 12 feet tall on the other side of the Here we're walking between Pemphis and the half-flower, some coconuts, the few hunek, octopus bush trees. You can see how tall the vegetation is across this point. Star sand occurs all along the beaches going to Hila'an, but it is particularly evident on the last point between Shark Beach and Hila'an Beach. The tan colour shows which ones are alive, white ones are dead shells. Forams are unicellular protozoa with calcareous shells, but containing hundreds of symbiotic algae, or zooxanthellae. But these are not dinoflagellates like the ones in the coral symbiosis. They are diatoms, which produce oil as a storage product, and this allows the living cells to keep floating to the top as waves roll the sand about. Under a dissection microscope, we can see that there are also remains of other tiny organisms, such as small snails, and many unrecognizable fragments of larger shells and coral, now only about 1 millimeter across. The orangey balls here are a star sand in the genus Calcarina. The most striking form here is Bacula gypsina, which gives star sand its name. It is about 2 millimeters from tip to tip. When we get to Hila'an Beach, we see that some of the water near shore is brownish. This is a so-called red tide, and it occurs frequently at this particular part of the bay. Under a compound microscope, we see that they are dinoflagellates, single photosynthetic cells. There used to be similar red tides at the east end of Tumon Bay that were there when the tides were low in the daytime, and the dinos became trapped in that corner of the bay rather than being swept out. But those blooms disappeared when hotel construction changed the wind patterns. The dinos are enjoying the nitrogen nutrient from the freshwater seeps and springs. There is a characteristic groove around the middle of the cell where there is a flagellum that gives them their characteristic twirling movement for which they are named dinoflagellates. Our red tides are harmless, but in other places, different dinos produce toxins that can be taken up by filter feeders such as clams and mussels and cause shellfish poisoning in humans. We arrive at last at Hila'an Beach. A zonation study of woody plants was conducted here by Sheila Muniappan in 1976. Her transect ran inland from the beach across Lost Pond to the cliff. The woody plant zonation begins in the strand vegetation with the thin line of two shrubby trees, octopus bush and half-flower. Half-flower, or nanaso, is a shrub which has flowers that seem to be missing half the petals and white berries that are used in traditional medicine. Hunek has a bunch of long, curling inflorescences that give it the name octopus bush. The color and shape of the leaves are different from nanaso. The zonation on the sheltered or leeward side of the island is compressed in comparison to that on the windward east side, where the half-flower zone is many meters wide. Here the half-flower zone is only a few meters wide before we reach the coconut zone. Here, in contrast, is a rerun of the walk through that zone at Pagat, but speeded up 4 times to keep it short. In the coconut zone, the woody vegetation is practically all coconuts. There's big coconuts and little coconuts and half-dead coconuts, but not very much else. There's some ferns down on the ground, a few wildflowers, scraps of a few other trees, but this is basically dominant coconut. And this zone goes on for quite a way. Young coconut, and the ground covered in coconut leaves. What Muniappan labelled Zone 3, Transition Zone, Tabarossi calls Back Strand. The ground here still has a lot of loose carbonate sand and gravel mixed in comparison to the limestone forest, where the ground is karst limestone with nearly pure organic matter collecting in the depressions. In Zone 3 we find still some coconut, but now some limestone forest trees such as this fago with its cluster of saplings around the base. There are some weedy vines, such as the false rattan in this zone. Among the understory plants is the native pepper, which is the habitat for some of the native tree snails. In wetter weather we might have found some on the undersides of the leaves. Native cycads were once abundant, but have been decimated by the cycad scale insect, literally reduced to 10% of their former numbers in just a few years. This one has only 2 small palm-like leaves growing from the top. The rest of the leaves are a big bird's nest fern. The introduced insects feed on the sap, and when abundant they kill all the leaves. The tree tries to make new leaves from stored reserves, but the insects kill them again. Soon the tree starves to death. You come here now, there's a few coconuts on the ground, but all of this, the leaves on the ground here are all pandanus leaves. And they're coming down from these trees up here. And as we get to the edge of this pandanus, we suddenly start to climb up and we see limestone rocks, and all of a sudden we're starting to climb up out of the sandy area, getting into all kinds of limestone here. And you see how the forest has changed. The limestone forest trees here are all native, including understory trees such as mapunao and paipai, or to give them the scientific names Muniapan used, aglaya and guamia. There is still pandanus and fago here. The tall trees include the native seeded breadfruit, banyan and fanniok or Marilia dendron. The tree trunks and limestone rocks tend to be covered with mosses and liverworts, this particular one known as lumot and harvested for nativity scenes. One of the many medicinal plants in the limestone forest is this tupanajuju, which has evidently been harvested. We got a look at a flowering specimen in good condition at the Guam Plant Extinction Prevention Program at UOG. That's as far as we could go before the trail to Lost Pond faded. So from here we hiked back to the starting point. There were a lot of people heading out to Hila'an in the later afternoon, all hoping to find enough room to spread out and enjoy the Memorial weekend. I'm just washing off my shoes.